Thank you for joining us today for our LTE device testing webinar. I'm Kelly Hill, reporter for RCR Wireless News, and I'm joined today by Cher Rowland-Hinton, Field Applications Engineer from Enritsu, Amit Malhotra, Vice President of Marketing and Product Management from Azimuth Systems, and Brian Helmick, Product Manager for Rohde & Schwartz. This program is part of our LTE device testing report that is available on rcrwireless.com. Some of the takeaways from that report are that devices must be tested for conformance to 3GPP standards for certification by device certification bodies, with features prioritized by member operators. And finally, for carrier acceptance to ensure compatibility with a network operator's unique network implementation. The proliferation of LTE bands, more intelligent devices, and more complex networks all contribute to increased testing, but costs and time to market demands are opposing forces. And finally, advanced LTE features and services such as carrier aggregation and VoLTE are putting new demands on testing as operators and OEMs work to ensure good performance and service continuity. So I authored this report, which is available, as I said, on rcrwireless.com. Some of the recent statistics from the Global Mobile Suppliers Association, I think, really illustrate what's going on in this LTE device ecosystem that makes it so complex. The GSA reported that no single band accounts for more than 50% of LTE deployments. 44% use 1800 megahertz, 27% use 2.6 gigahertz, 12% are using 800 megahertz, another 8% use AWS, and there's also an additional 9% that use some other bands. So as you can see, there's quite a band proliferation and fragmentation that is an ongoing issue in this ecosystem. When we talk just specifically about LTE devices and testing, there is a lot of activity going on. The most recent numbers from the GSA are that there were 680 LTE devices in the last 12 months. That's a lot of products to get out. And finally, adding to the complexity even more, we have FDD and TDD LTE, and while FDD has dominated the marketplace to this point, TDD is now incorporated into 10% of commercial LTE networks. And I believe they had an additional figure that there are 13 operators worldwide that use both FDD and TDD LTE in their networks. So all factors that are contributing to the complexity of the testing that needs to go on to ensure that these devices work properly. Some of the other interesting points that I thought came out of the reporting for this piece: head forms and hand forms in labs to ensure real-world conditions. This came out of a conversation that I had with Test Lab SGS, and it was in something that has been an advancement in response to real-world differences that haven't shown up in some cases until a product is out to market, most notably something like the iPhone early snafus with antennas that didn't perform as well as they were expected to once they were in actual consumers' hands. Handset manufacturers taking a more active role. I heard this from companies across the ecosystem, from Sprint to the test and measurement companies, that the handset manufacturers have increasingly taken interest as their brand becomes more important in the ecosystem as well. When I spoke to Carl Anderson of Enritsu, he mentioned that standards bodies are more proactively taking testing into account. So if you're thinking about testing earlier in the process, you get better testing because you've already put some thought into how you're going to approach that. And then also the fact that equipment is advancing to support network and device evolution, and also responding to field needs for lighter and less expensive equipment, which I think our participants today probably know very well. So on that note, we are going to get into our first presentation, and that is going to come from Cher at Enritsu.
Thank you very much, Kelly. Thank you everyone for joining us. So I think, Kelly, it is true what you said in the previous slides, but I'm not so sure about the last comment, which was that we have adapted the less expensive equipment. So I think that'll be a challenge for the folks on the test side. So can you please advance to the next slide?
Sure.
So I saw the rest of the slide presentations today, and you're going to see that I think the test equipment world has done a really good job of coming to similar conclusions on the design stages. Here they're listed. First, we start off with the magical engineers that are able to take a piece of wafer and turn that into a chip that actually conforms to all of the specifications that we have today. And then we have the folks that actually take the brain and turn it into a device that may interact with a human, or we're going to see a lot of devices that are going to be interacting with other machines. So then we take the device, the product that we think we have working, and we move into UV conformance testing, and just to ensure that the final product then is able to perform all of the required functions. And these tests, again, are well scripted, well designed, rigid tests for the product to make sure that it conforms to the specifications. Then we move into a new realm, which is carrier acceptance testing, where the carriers take the product and prepare it to actually be deployed on their networks and all the different flavors that we have. It was interesting in Kelly's report that I learned today that some carriers actually do not require carrier acceptance testing above and beyond conformance testing, and that was a big shocker for me. So that was an interesting point in Kelly's full report. And then after the carriers believe that the device functions as they expect it to behave and meets the requirements that they add on to the device, they then put it into their interoperability testing labs where they see how the device performs with all of the other equipment they have in their network. And then finally, the device then has to meet the real world where it's deployed in a live network where all carriers' networks are overlapping, and despite the best intentions of all the engineers that are working in these, we have all of the mistakes and wrong software loads that are loaded out there, and see how the device performs in that environment. Kelly, can you proceed to the next slide, please? So here is the exact same thing with pictures. So UEs have different requirements depending on the region and the operator, and even the same terminal may require multiple tests. So there's a new bubble here on the right side called application testing. It hasn't really been formally mentioned in the design and test cycle before, but it is really hitting us hard. So you'll see it here listed somewhere between conformance testing and carrier acceptance testing, but we also see it after carrier acceptance testing and in-field testing. Okay, Kelly, can you please proceed to the next slide? And at Anritsu, we do offer a product portfolio that covers all 4 stages of design, and including application testing. So if you have any questions about any of the stages or would like to get more information, please contact Anritsu. We'll be happy to share more information and details on these products. Okay, Kelly?
Okay.
And thank you. And so now we're going to talk about the meat of the slides that the concept that I'm presenting here is that the impact of applications and how that is impacting our testing. And in Kelly's report, she has a lot of great data points, but the basics are listed here in the 4 points that all OS suppliers have a program to test individual applications. So this may or may not actually involve a device. So they're testing the software applications, but we're not so sure that they're linked well with the testing of the hardware that we will actually run the software on in the real world. Most conformance and carrier acceptance test regimes configure a device under test in a specific way. This is another way of saying we do our best. We test applications on a device configured in certain ways because there's no possibility of testing applications on every configuration that a device could be in the real world. Apps behave differently when operating on an actual device than in a lab environment. My guess, as I see it, is that application testers want a perfect cellular connection when they test their applications. They do not want to worry about poor RF conditions and how their apps would behave on the edge of the cell. They're looking to test the software. So when the device actually hits the real world and actually sees various RF conditions, we expect that the apps would and do behave differently. Okay, Kelly, we can move on to the next slide. So where does this leave test equipment? We've just said the applications are adding another level of complexity to an already growing complex network. So what we have seen, and I learned this from Kelly's slide, is that testing times are now growing from 100 hours per device to approximately 400 hours per device on a smartphone. So in this slide, the idea that we're trying to get across is that for application testing, we need to somehow take the growing complexity of the network out of the equation to the best extent that we can. So in this picture, you'll see that a piece of test equipment is inserted between the device and a hub connecting to an assortment of servers. What this can do is allow a device manufacturer or an application or a combination of the two to rely on a cellular network in various conditions that you can control on a simulator, yet maybe you want to connect to some real servers, some deployed on live networks. Maybe you're testing an application to see how the application works when it connects to live servers. Will the live server actually authenticate properly? So now test equipment is actually becoming just a spoke in the wheel of testing. And the major requirement that we're seeing is that test equipment must be flexible to accommodate the growing magnitude of configurations and requirements for each individual application. Okay, Kelly, can you proceed to the next slide?
Okay, one thing, honey. Can you please try to see that phone more often at the front desk?
Here are two of the application testers that Enritsu sees most commonly in the application test world. And if anyone, again, has any questions, my experience lies, I'm in the Pacific Northwest. You can imagine that who my influencers are up here. But with application tests being one of the biggest challenges that we're facing, I will argue that something has to change. The complexity of the applications are growing, the complexity of the cellular networks are growing. So I think what our challenge in the test world is to become much more efficient in testing only what is the most important. And the final statement I'll make is that I think we are, in this industry, we have a lot of practice at testing the complexity of the cellular networks and the mechanics of how they're growing. So adding bands, adding frequencies, adding features. What I don't see that is very deep in our industry is a knowledge of data mining for tests that are important, that will expose where the most common problems are of devices running multiple applications on very complex networks. I think the challenge for our test industry, again, is to learn from our partners in the software world how to look at statistics and analytics of the cellular network to have a more comprehensive approach to testing. And that concludes my presentation. Kelly?
Okay, great. Thanks, Chair. Yeah, I think that level of complexity and the ongoing challenge of applications, is definitely a pain point. So, all right. With that, we are going to move on to our next presentation from Azimuth Systems, and that is Amit Malhotra. Amit?
Thanks very much, Kelly. Can you hear me all right?
Yes.
Great. All right. My name is Amit Malhotra. I'm Vice President of Marketing and Product Management for Azimuth. I'm really excited to be here today. Azimuth is a provider of mobile performance test systems, counting the industry's leading operators, OEMs, chipset pioneers, and infrastructure vendors among our customers. So, we've got quite a bit of experience on the mobile performance test side, and just to be clear, when I talk about performance test, whereas conformance is, whether the device works as expected according to the specifications, performance is how well it works, because in today's environment of growing competition with increasing saturation of the marketplace, it's not simply whether a device works, but how well it works, how much better it works than its competition. So if you can advance to the next slide.
Sure.
What I want to share right now is some of the key industry developments that we see that are driving our business right now. And first, at a high level, we're all aware of the various technology developments at the network, application, service, device levels. But what's important is what's driving all of that. We see three key drivers. One is obviously consumer demand. So you've heard from operators about how they're unable to keep up with the insatiable demands for data from their subscribers. And that's running right into another issue, which is spectrum constraints. So they're trying to become much more efficient in the way they use their spectrum. And then another key one, which is not as obvious, is the operator need to optimize the user experience and the network impact. So especially with the proliferation of OTT apps that are loaded on the device by the subscriber without the operator's knowledge, but then can reach back into the network and have adverse consequences, operators are really striving to make sure that for a given user experience that is acceptable, that the network impact is as minimal as possible. Another area of development is the specific technologies, and we see three key technologies really driving industry activity this year, including, as you said, TD-LTE, LTE Advanced, and VoLTE. Now, TD-LTE, what's interesting about that is that, whereas you quoted some statistics that showed that there's a minority of operators that are using TD-LTE today, in December, the Chinese regulatory agency released the licenses for TD-LTE to the country's operators. And if you think about the fact that to date, the U.S. has really led the way in terms of LTE deployments. With that stroke of a pen, the operators in China now, whose subscribers far outnumber the operators in the U.S., are now going to be advancing LTE, which means that TD-LTE is going to become a much larger part of the ecosystem than it previously was. LTE Advanced, again, becoming more efficient at delivering higher bandwidth that customers are demanding. And VoLTE, which is both about more efficient use of spectrum and network, but also about better control over the user experience. So those are driving industry activity. What's interesting there is that because all of these technologies are in their infancy, the test plans are immature. There's a lot of test equipment and test platforms out there, but the operators and OEMs who are doing the testing, they don't necessarily have all the references they need to develop test plans that they can conduct repeatably. Another driver is the exponential growth in RF complexity, particularly driven by LTE Advanced, which includes features such as carrier aggregation and heterogeneous networks. So now, basically, a device doesn't just see a predictable number of base stations, but it's seeing base stations, small cells, etc., shifting in and out of view pretty rapidly. So trying to be able to test devices in those types of environments is a lot more complicated. And finally, KPIs have shifted from network-centric, so things such as throughput, to user-centric, what the quality of experience is. And that's a reaction to the fact that there's all this under technologies, and ultimately what's most important is what the user experience is. And I'll talk a little more about that as we go through.
Okay.
So if we go to the next slide. I'm going to really skim this slide because it mirrors what was shown in the previous presentation in terms of the progression of testing. And a couple things I'll call out is you'll see this progression starting in R&D through conformance testing to performance testing, which is, we include carrier acceptance in that part, because by that point it's assumed that a device does conform. It's a matter of how well it does on that particular network for that particular operator's subscribers' expectations. But then another very important aspect of testing is post-launch testing, particularly when you think about the fact that the cost of fixing a problem is exponentially greater once that problem has proliferated across devices that are in subscribers' hands. What we're finding is a lot of operators have pretty significant return rates. They're trying to get those return rates down. And so they're basically trying to push upstream more testing just to avoid problems that are seen, after launch. So there's a significant amount of post-launch testing, and that post-launch testing also then informs better product development when you think about going back to the R&D stage. The chipset manufacturers, OEMs, I should say device OEMs, and operators all do aspects of this. And in fact, there are certainly instances where an OEM will replicate an operator's test plan prior to submitting the device, just to predict the success of that device, in that operator's test plan. So let me go forward to the next slide. Thank you. So here you have the key challenges of testing today. One is that explosion of technologies at various levels is also exploding the scope of testing. And rather than talk about adding a whole new box for each type of test, we've got to come up with a seamless platform that can add new test cases without major upgrades, primarily through software. Changes at each of these layers is making it more challenging to identify root causes, which is why rather than try to keep up with all of the different network level, device level KPIs, as the scope of testing increases, it's important to keep an eye on the ultimate goal of user experience KPIs, and then on an exception basis, trace back to the lower level KPIs, and I'll describe how that's done. The competitive pressure to minimize time to market and time to resolve issues ultimately requires faster correlation between the lab, the field test organization, the network organization within operators, and then as well as with their ecosystem partners who might be device vendors and OEMs and chipset vendors. And finally, there's the network impact for a given user experience, and what that means in terms of testing is better end-to-end analytics from the user experience to the network device interaction, so that once you've benchmarked what an acceptable user experience is, how to ensure that the network impact for that user experience is acceptable. So let me move on to the next slide. Thank you. So one of the things that we at Azimuth are focusing on, and we think is critical for test and measurement in the mobile industry, is to make testing more and more efficient. One way to do that is to ensure that the contained and controlled, cost-effective environment of the test lab can be outfitted to better reflect real-world conditions. So if you think about the way subscribers typically use their devices out in the real world in various types of network conditions, using different types of applications that stress the network in different ways, We've got to try and replicate those in the lab, but as efficiently as possible. In the early days, if you look at this, if you look at this chart, the dotted line at the top, which is this mythical real-world conditions. So we've been striving to advance mobile performance tests to asymptotically approach real-world conditions while remaining efficient and cost-effective. So in the early days, we concentrated on radio frequency channel emulation, and in that environment, basically, which is still widely used in the industry, a device is actually connected to network emulation equipment via cable. And then network information is fed to the device, typically in the form of standard channel models for generic scenarios such as mobility, urban scenarios, high-speed train, etc. And then the reaction of that device is measured and analyzed, and then design decisions based on that. But while that has worked pretty well in many phases of testing and is still widely used today, you can imagine that it's not really the way customers or subscribers use the device. For one thing, it doesn't actually exercise the antenna, important component. So the next level up from this is over-the-air testing. So now you're basically in the same type of lab environment, but you're testing the device in a shielded chamber that is radiating the network information so that it's actually fed through the antenna, which is more realistic use, but still not quite near real-world conditions. Field playback is more real-world because now instead of being the device these standard channel models, we're actually able to record network information on a real drive test out in the real world, and then bring that back into the lab and feed that to the device on a repeatable basis. So you can do a drive one time anywhere in the world, capture those conditions, and then bring those back into the lab and replay them over and over again. But all of that still is conducted not through the antenna of the device. So what we're presenting today is really kind of the latest advancement in that progression, which is what we call intelligent over-the-air, or IOTA. And that's basically testing the device through the antenna, replaying field conditions, so it's actual drive routes that operators and OEMs are familiar with, but applying user experience automation, so there's certain essential applications that are being exercised, such as voice calling, messaging, data, video. And then finally, for all of those scenarios, applying device network analytics. So if two devices under the same network conditions have different performance for data, why is that different? Or if they are equivalent, do they differently? So to take a deeper look at that, if we can go to the next slide. To validate IOTA, what we did is some independent testing where first we took 3 LTE devices on a drive route, so they're actually being exercised on the live network in conditions that are pretty typical for subscribers. And then during that drive, we also captured the network information. We then tested those same 3 devices, replaying those same network conditions on the IOTA platform. And what you can see here is that the curves for the equivalent testing, either on the live network or in the lab and on IOTA, while they're not ever going to be completely the same, they actually are fairly similar. And in particular, the relative performance of the three devices at different phases of the drive test have the same ranking. So this system will predict the performance of the different devices as they might occur on a given drive route out in the live network. And what's important about that is that there's a lot of testing that occurs today where either an OEM or an operator will deploy a field test team to over a specific drive route to try and replicate an issue that was seen previously. And because the network conditions may be different, that field test team may not immediately replicate that issue, and a lot of time is spent trying to essentially get down to the heart of the issue out while folks are out on the road. So all of that now can be reduced to testing that's done in a much more controlled environment, which is the lab, but again, using a lot of the information that was collected out on the live network.
Okay, great. If anybody has any questions on those, they can go ahead and contact Amit at Azimuth. We do have one more presenter, and we'd like to leave some time for some Q&A from the audience. So I'd like to move things along to get to Brian Helmick of Rohde & Schwartz. Brian?
Yep, can everybody hear me?
Yep, and let me advance to your slide. There we go.
Okay, so I'll get through this as quick as possible. I'm going to talk about LTE device development challenges. In other words, what are some of the underlying business drivers for bringing LTE devices to market and some of the challenges on the test side? First thing is time to market, because coming to market a week or a month or even longer late with a new product with the latest and greatest feature, and if this feature is late, it can mean the difference of tens and millions of dollars. The device market is extremely competitive. The manufacturers, they really need their devices in the stores earlier than the others with similar features. And operators need those devices in the stores as early as possible to compete with the other operators. So it's really a very, very competitive market, ultra competitive. And then there's the cost. Cost is another underlying driver, because there is a limit to what a consumer will pay for a device and what they'll pay for the monthly service. This means that there's a limit to what an operator will pay the device manufacturers for these devices, and there's a limit to what the device manufacturers will pay the chipset suppliers. There's a limit to what the device manufacturers will pay the test labs for testing, and it all flows downstream. So with this in mind, everyone is always looking for ways to decrease the cost of getting the devices to market and everything around there. Quality is critical. That's the third business driver. There's nothing worse for an operator to get a device returned to the store due to problems, or have a subscriber move to another carrier because of, at the end of the day, it doesn't matter if it's device or a network issue. The way a consumer looks at it is it's a problem with the carrier. So device manufacturers, they will eat the cost of that return device if there's problems found. Otherwise, the operator ends up eating most of the costs. So everybody is interested in quality, quality, quality. All right, go ahead to the next slide. Okay, so this slide is one of two slides that go over the key technologies and the related tests. So the test areas, along with the technologies and applications. And I'll talk about the test lab challenges at the end because they're all pretty much the same. So one of the test areas is RF. For RF, device manufacturers, chipset suppliers, test labs, operators need to worry about the technologies in the device. So it could be GSM, eGPRS, WCDMA, HSPA+. There's LTE, FDD, and TDD. And for RF, there's conformance, There's supplemental RF conformance, including that's carrier acceptance. And you could see margin search and sweep mode. What is that? Well, it's also important to be able to sweep through all possible bandwidth combinations, power levels, not just what's specified in the conformance standards. And in addition, instead of just getting a pass-fail at the end of a test, you may want to margin search so that you know how well your device has passed or how badly it's failed. This gives you the true performance of a device instead of just a fail, which doesn't always tell you much. For RRM conformance and supplemental conformance, carrier acceptance, you also have WCDMA, HSPA+, you have LTE, FDD, and TDD, and you've got interrat. So interrat between LTE and GSM, LTE and WCDMA, LTE and TDS-CDMA, LTE and CDMA, and then LTE to LTE. Performance is key. So this means data throughput testing or audio and video performance in a VoLTE call. Device aggression, how aggressive a device is to get onto a network. Call and handover reliability. So can I attach 1,000 out of 1,000 times? Can I do 1,000 out of 1,000 handovers, or do I have a reliability issue? In performance, there's also conformance. So performance is now in the conformance specs, 37901, 3GPP spec. And of course, there's a ton of carrier acceptance, data performance test plans, and audio video performance test plans. There's really a lot across multiple carriers. Okay, next slide, please. So another test area is location-based services. Again, GSM, eGPRS, WCDMA, LTE. There's AGNSS, which is using satellites, GPS, GLONASS, and now the Chinese satellites, the Beidou Compass constellation. Galileo will be coming soon. These need to be tested. There's also network-based positioning, OTDOA, and even OTDOA with carrier aggregation. Enhanced cell ID, another network-based instead of satellite-based location determination technology. There's conformance related with LBS. There's carrier acceptance related with LBS. And in the world of this test area, LBS testing, there's also a lot of field to lab because GPS, GNSS is downlink only. It's quite easy to record that signal and then replay it in the lab, so there's a lot of that as well. There's IMS, VoLTE, RCS, Wi-Fi offloading. This is one huge test area right now because of the VoLTE deployments and everything around it, including what happens when you're maybe in a VoLTE call and you need to transition to SRVCC or transition to WCDMA using SRVCC, or Wi-Fi with Wi-Fi offloading. There's conformance, there's carrier acceptance, there's audio quality in VoLTE, there's audio and video performance in VoLTE, and keep in mind VoLTE is not just audio, VoLTE brings video to the equation as well. And then protocol, there's thousands and thousands of test cases for protocol, covering all the technologies I mentioned before, including interrat, between all the technologies I mentioned before, conformance and carrier acceptance. And if you've been paying attention to the test lab challenges on the right side, you can see that there really is a common theme to the challenges that labs have. The number of test cases, the number of bands to be tested, the test times just add up to absolutely huge numbers. And the number of pieces of test equipment needed to cover all these technologies ends up being a big challenge to test labs. Okay, can you go to the next slide? All right, so what we see, Rodian Schwartz, is a need for test boxes, test systems to be more flexible. I think Azimuth, they brought this up before in the previous presentation. These pieces of test equipment need to be more flexible to support whatever a customer needs to do in the lab, across technologies, across applications, because buying a new box or a new test system just to cover a few other technologies or applications is extremely painful. It just leads to, especially in test labs, increasing test lab costs. For example, with Wi-Fi offloading, now you need Wi-Fi and LTE. So does that mean another box, or can we please have that in one test system? It's also important to make sure that test equipment should be upgradable to the latest versions of technologies. Again, I think Azimuth, they brought this up. For instance, release 10. There's category 6 and even category 7 with end-to-end data rates of 300 megabits per second on the downlink and 100 on the uplink. It's important to not need a new box just to test that, or hundreds of thousands of dollars in upgrades to make that happen. So that's the idea. That's the method that RNS has taken with the CMW 500. All right, next slide, please. So this is kind of an eye chart here. I'm not going to go through all those systems, but the key point here is all of these systems use the same box, CMW at the core, as a network emulator. From protocol to RF and pre and full conformance, RM, data performance, audio video performance, location-based services. It doesn't really matter. You can just build up one box to any type of system. It's something that needs to happen, flexibility, to reduce the cost, and as the technologies get more and more complicated, we need to reduce the size, the number of boxes, and ultimately the cost that gets thrown at the UE manufacturers, the test labs, the operators, because we can't just keep increasing prices. And that's it.
Okay. I think it also gives, kind of a visual view of, some of the complexity just in terms of the different test setups. And then you have to think about bench space, and you have to think about, having the, the resources and the space to, to be able to set up for all the tests that you'd like to run.
Yeah, I want to add that, I mean, all test equipment suppliers, we should keep looking to ways to reduce the scope, the size of test systems, the number of boxes needed. I mean, for instance, we've brought in baseband fading into the CMW 500, which reduces the need for external baseband faders or RF faders. Mm-hmm. And this decreases the size of, for instance, an RM system almost by half.
Okay. All right. Well, that's the direction that you see going forward. Brian, I'm going to go ahead and we're going to go ahead and start our Q&A. Audience members, I'm going to launch a poll here for you to participate with us. And our first question today is going to be, what do you see as a disruptive force in testing? I'm going to go ahead and launch that poll. It's a multiple choice. And we're going to leave that open for a little bit less than a minute to give you folks a chance to participate. Brian, I wanted to start our first question off with you. And you made a reference to Category 6 and even Category 7 devices. When you start talking about carrier aggregation, we're looking at LTE data rates that continue to increase. And Category 6 devices being able to use 40 megahertz of spectrum on the downlink in order to hit that 300 megabits per second speed. Now, how do you see, how is Rohde & Schwartz approaching that in terms of the challenge there for testing?
All right. Thank you, Kelly. Yes. So for Category 6 and even Category 7 devices that would even have uplink carrier aggregation, we again feel that this needs to be a feature that's supported with existing test equipment in someone's lab. No need for another box. That means you have to design the test equipment with upgradability in mind. So at RNS, the CMW 500, you can actually add a third and a fourth TRX board, and you can do a simple upgrade of the baseband modules to support these data rates, and not just support these data rates in test mode, but actually support these data rates with real user plane data. All of this is important, and it needs to be able to be done for something that's not a ridiculous price.
Okay. I'm going to share the results of our first poll, and it looks like in terms of what our audience sees as disruptive forces in testing as the growing complexity of CAT and IoT testing. Application testing came in second with 50%, and data performance testing was in there as well. So let's go over to Cher and Enritsu, and maybe you can talk to us about how new technology how you see new technologies fundamentally altering how LTE device testing is going to be undertaken in the coming years.
Well, that's a great question, and I actually saw a question from someone that has since exited the webinar that was asking about statistical testing, and I had mentioned this in my presentation, that a more efficient way to look at an umbrella of application testing is to say statistically in the live network we put a device out there, where are we failing, how can we look at the failures and test what is failing in the field versus testing in the lab what we know how to test. And we're very good, and Brian did a great job of explaining that. Our history, our industry is very good at testing what we know we need to test. And I think where I see interesting things happening is when you have, and I really think the expertise here is going to come from the UE manufacturers themselves, folks that are looking at a statistical view of where devices are failing in the field. That will, number one, train the device manufacturers to identify the issues on their side, but will also flag to the carriers where the problems are lying in the network side. So we all expect there will be very interesting things happen on LTE cell edges. And it would be, to Brian's point, extremely expensive to try to set up environments in a lab to mimic a cell edge condition with multiple carriers, very noisy, very low power, lots of multipath fading issues for all the technologies. So I think what I'd like to see happen is UE manufacturers start training us on the test equipment side and on the carrier side how to look at overall statistics of device performance in live networks, not lab testing, but live networks, so that we can then take that information, absorb it, and maybe create an entire new set of testing that can be done on existing equipment to not add additional cost. That will increase the time for testing, but this is something I think that will be really valuable, because quite frankly, as you saw all of us say, the networks are growing in complexity so quickly that we need a new approach. We cannot use traditional methods of testing features and combinations of technologies and bands as we've done in the past. And I think that will be a really exciting change to our testing approach for LTE Advanced. Okay.
Audience, I'm going to go ahead and launch our second poll question, which is, what is your biggest challenge in terms of testing LTE devices today? So that would be nice to hear from you folks out there who are watching in terms of what your views on the subject. In the meantime, I want to get to a couple of questions from the audience. There were a couple of related questions on why carriers are more comfortable with frequency domain versus time domain in terms of LTE modes, FDD and TDE, and kind of an accompanying question of why did most of the carriers worldwide choose FDD over TDD LTE except for China. I'm wondering if any of our experts here might have some insight. Obviously nobody can speak for the carriers, but is there anything inherent in those spectrum modes that makes one a particular choice versus the other?
Yeah, this is Amit. So I actually used to work for a carrier, and I know that it's quite a historical artifact that the operators prefer FDD. That's the way the frequency bands were sliced up in those pairs, and it's to protect the uplink from the downlink, particularly because the two had very different characteristics.
Can you speak up a little bit, Amit? I'm having a hard time hearing you.
So now that spectrum is much more scarce, and uplink and downlink are really starting to approach each other in terms of their characteristics and how much bandwidth is used. The carriers are becoming more comfortable with TD-LTE. So China, we talked about, Sprint here in the U.S. is deploying TD-LTE as well.
Okay. Would our other panelists like to weigh in on that at all? Okay. So
I was just going to say that lots of carriers. Sorry, go ahead.
Oh no, go ahead.
I was going to say carriers in North America have paired spectrum, so they've got a downlink and an uplink 20 megahertz or 10 megahertz, 5 megahertz block. Someone like Clearwire, but now Sprint, now SoftBank, they've got all the TDD non-paired spectrum at 2 gig or 2.7, 2.6 gig TDD 41, and that's just a legacy thing as Azimuth they talked about before. So.
Okay, great. I'm going to share the results of our most recent poll. The biggest challenge covering the latest technologies, including VoLTE, RCS, etc., and also the increasing complexity and number of tests, which I think all of our experts have addressed. They definitely see as a challenge industry-wide as well. So let's continue with a couple more questions. Shir, I wanted to go back with you and ask, what's the most difficult part of your testing process?
Okay, thank you, Kelly. In my area of the world, the most difficult part of testing is trying to keep up with the carrier acceptance tests. So I think the way the specs develop, we are all kind of on level footing as far as everyone understanding what the specs are saying, and then we all have discussions that interpret them and implement them. But really, it's the carrier acceptance tests that evolve daily. And keeping up with that is a real challenge, especially given that I in the Northwest support 2 carriers, and keeping up with the rapid pace at which they create carrier acceptance tests and then want us to help support carrier acceptance tests is our biggest challenge.
Okay, great. Brian, we've got a specific question for you. The sweep and margin. Sweep mode and margin search, and we have an audience member who would like you to explain more about that.
I was on mute. Sure. Yeah. So I mean, for instance, it depends on what we're talking about here, but in the world of RF testing, margin search enables you to find the margin in dB of a test case, and it does it in steps. For instance, you would vary the downlink level or interfere level until the test case data throughput level, RF performance level, bit error rate limit, whatever the test case is doing, is reached. So you're effectively making conditions easier or harder for a device until the test passes or fails. In other words, it tells you how good or bad your phone is at certain test cases. And this is quite critical. I mean, I guess it's critical at all levels. You can have an operator that could have a device that passes 50 test cases and those 50 test cases are specified in conformance, and this is great, but maybe there's still some issues in the field with this device in certain conditions. And if you have an idea that it's something to do with receiver performance, you can go and run the Chapter 7 of the 36521 RF conformance spec, which is all receiver tests, and you can start margin searching to see how well these devices pass. If they're just passing by a very little margin, and you've got other reference devices that pass by a lot more, then you can quickly narrow down that this is actually a problem with the device's receiver performance. And this idea applies for data performance testing, transmit performance of device. There's a lot of ways that you can use margin searching. The reason why I would say it's not used as much as it should be today is because there are so many test cases to get through to begin with for carrier acceptance and conformance. It's gotten to the point where it's, you know, it could take a month or 2 months just to get through the tests you got to get through. So it doesn't give you a lot of time to do margin search. So that brings up another point. We got to really look at the test cases that are the most important. This was brought up by Sharon and Ritsu. Somehow, some way, a lot of the legacy tests, a lot of the test cases that do actually never fail, or fail once in a million times, somehow we got to capture statistics or something and potentially get rid of those tests at the conformance standards and with carriers. Another idea, which has been kicked around the industry, I don't know how serious this will be taken, but a way to reduce test times is if we can get carriers potentially or those in charge of the test requirements to allow for statistical randomization of testing. So you might have, say, 5,000 test cases, and the test cases out of those 5,000 are randomly chosen, so maybe 10% to those 1,000, and that reduces the test time by 90%. So there are some ways that we can get away from, you know, months and months of testing and get towards this performance margin search type testing, and that needs to be discussed with the guys in charge, and mainly the operators.
Yeah. Okay. Well, that's an interesting concept. We'll have to see if that comes into play. I've been Jen Henton from Enritsu, Amit Malhotra from Azimuth Systems, and Brian Helmick from Rohde & Schwartz. Thank you all for participating with us today.